Everyone. My name is Sam Sharaf. I'm a product lead with Salesforce Agent Force AI team. My responsibilities include basically leading the multi-agent initiative at Salesforce with Agent Force and how agents talk to each other, how they discover each other, register, and also the whole agent interoperability, which I was talking to Ramesh that, hey, 25 years ago, that was the age of internet, right? We were looking at how internet nodes, when a new computer is plugged in to the internet, how is going to be registered, how the MAC address is registered, how it is um, found on the web of network. And we are pretty much in the same era again with the agents. So if you, Ramesh, if you can go to the next slide. So I wrote this earlier this year, which is basically a white paper on 10 factors for agent interoperability system. So when we think of multi-agent systems, there are a lot of considerations because just making the agents talk to each other is in some ways a problem, but not the whole problem. So we need to take a step back and say like, hey, what are the key principles of agent interop? So one principle which I introduced was called agent metadata card, and that pretty much kind of analogous to the LLM card, which is like, hey, you go to Hugging Face or OpenAI and you look at the model, and the model basically describes is like, hey, this is my context window, this is how to use it and stuff. In the context of agent, I think it becomes important that we define what are the agent capabilities are, if that agent can handle PII, PCI data, is it a HIPAA compliant in the context of healthcare? And then going from, and in the context of agent registry, we'll index it more. And then we go into identity and authorization, right? So that becomes very important is especially for cross-domain agents, which are across network domain. How do agents authorize with each other? How do they share identity? And is there a notion of role-based access control? And then very importantly, agent versioning, registry, and discovery, right? So as agents improve, we version them, right? And there is a centralized place similar to DNS registry for web. Are we also registering these agents and providing a good mechanism for discovering the agents? Agent-to-agent communication becomes important. Like I said before, that's at the core of it is in a multi-agent system, how agents are able to communicate with each other. And then you can call it the agent orchestration engine or the gateway router. Different people are using different words, but there needs to be some mechanism where there is a concept of a router which is involved in also routing the requests when we're fast going towards the time of thousands to millions to maybe billions of agents, right? So how does the various routers across different systems working to orchestrate these agents? And then, of course, there's state and conversation management. How does agent orchestration works in the context of multimodal agents? So that becomes important as well. Observability, monitoring, and trust scores. So at Salesforce, trust is our number one value. So everything we do is basically underpinned by number one, is it secure? Is it safe? Would the enterprises, the businesses who use us would trust us with that? So that becomes important. Security and compliance, of course, in regulated industries, that becomes important. And then lastly, what I call the non-functional requirements, right? Scalability, performance, latency, those become important. So let's move on to the next one. So like I said before, since we are talking about the agent registry, specifically in this topic, I'll index on a little bit on agent card. So this also made its way into the Google A2A protocol, which you probably already saw or heard. And so the key concept there is what are the key metadata fields in agent, which when we register it, it basically gets registered with those. So for example, unique agent ID, human readable name. Who is the publisher? Is it Salesforce? Is it MIT? Is it Microsoft? What are the capabilities of the agents are, right? What jobs it can do, which can lead to like, hey, runtime discovery of agent. I'm looking for an agent which can do X, Y, and Z. And from there, the discovery service will help find it with its endpoints, what kind of trust score it has, and what kind of security requirements it fulfills. So all those become important. Next slide, please. All right, so when we go into agent registry and discovery, the key definition there is pretty simple, right? A centralized or distributed place where agents register capabilities, endpoints, versions, and metadata. And I think the key part of that is it should be able to handle dynamic updates when agents come online and offline. So the way we are designing at Salesforce is basically with the mindset of crawl, walk, run approach is um, have a registry with a notion of agent cards so that there's a standardized agent manifest, and that basically becomes compatible over time as the organization-wide and industry-wide adoption occurs, so that and there's going to be various registries, right? Um, and it's great to see an initiative by Dr. Ramesh or Nanda. I think that would help propel this movement. But I think initially there will be a lot of individual organizational registries. And I think that's where it becomes also important is how these registries are able to communicate with each other that, hey, these are our agents which can talk to the other agents across domain. Can registries share that information across each other across domain? And that becomes so. If you go to the next slide, Dr. Ramesh, there is a picture there which will help with some of the wording I'm mentioning here. So as you probably remember, DNS, right? DNS became famous 80s and 90s, right? So the concept was like, hey, a human readable name instead of like trying to remember the IP address of where this service is located, right? So it's very similar to the phone book of the web. So agent registry at the same time, and it's right now in this picture is a centralized agent registry, but um, if even if you have distributed registry, it's the same concept as um, it's basically will become the directory of the agentic web, and it will have agents and not just registered agents, but identity. The registry should provide identity verification, some kind of trust score, like, hey, this is not a malicious agent, it's verified, it's trusted, it's secure. And like I said before, how the agents can be discovered through its capabilities, through its functions, and all that. Next slide, please. All right, so key points, just as DNS aligns humans and machines to the same naming system, a registry for the agentic web is critical for interop and trust. And as you can see, I've scaled the agents to many, many, many to illustrate the point is that, hey, number one is the agents are only going to grow, right? So discovery and registration services become more and more important. And then also, I think very, very crucial to that also is how these agents will be able to negotiate, right, transact and collaborate. One topic here also important is human in the loop. When does escalation occurs to human, both at a time of discovery as well as registration? Because initially, I think human in the loop will be really helpful to have some kind of uh, intervention, especially when errors are arising. But over time, as we go from semi-autonomous to completely autonomous systems, these registries and the agentic web needs to mature to a point where it's more autonomous and automated. So I'll take a pause here, Ramesh, and see if folks have questions or comments.
Let's do that. This is amazing. Thank you. Thank you, Sam. And wonderful to hear that you're the original designer of kind of the agent schema, agent card, agent facts, many of the concepts that are coming together. It's kind of your passport that you're carrying with you beyond your phone number. So that's fantastic. One natural question here is, how would this evolve in organizations that are catering to its own clients? Salesforce is one of them. Microsoft has co-pilots. How would it happen? Kind of, let's call it the intranet of the agents versus the internet of agents. So the registries that are within an organization versus registries outside. And more importantly, when somebody wants to, it's easy to call from intranet outside, but when somebody from outside wants to call an agent that's inside the intranet, how would the registries play a role?
Yeah, great
This is
question.
one of the major thing on our mind at Nanda as we are working with you and many others in
Right.
designing the quilt of registries.
Yes, yes, definitely. And great question, and something I probably didn't highlight. So at Salesforce, what we are doing actually is we are building, and I'll use your terminology, is intranet first. Because at Salesforce, we have, as most of you know, um, Service Cloud, Sales Cloud, Marketing Cloud, Commerce Cloud, and then we have industry clouds, right? So each of our clouds are building their own agents. So within our organization, we kind of have an intranet of agents. So our first problem actually is how do we make these agents talk to each other? And that's a big problem. So I pinged Dr. Ramesh earlier this morning, like, hey, I got into an urgent product call. And literally the discussion was this, like, hey, how are we, our very, very top level executives want to know, like, hey, how are we delivering for our own internal agentic use cases, right? How are we making the agents talk to each other? So that's problem number one, what we're calling customer zero. And then from there, we scale to like, hey, now we have solved this. Now let's also make that these agents, like our service agent, our marketing agent, it's also externally accessible. So in that context, going back to your Internet of Agents terminology, is can we start publishing these on our, let's say, agent exchange? And then let's say Google and Microsoft and Amazon, they can go to their registries, can go to connect with our agent exchange and figure out like, hey, here is a registry which has these standardized agents which can help interoperate with our agents.
Yeah, I'm taking the luxury of showing, the current mental model for this lightweight index, which we're calling the Nanda quilt, and it's really interesting to hear that it's happening in real time while you're on this web
Yes.
webinar call. You're getting called in from within Salesforce to deal with this interoperability issue and customer zero. Um, I'll ask the same question that I asked, Dr. Guha from Microsoft, which is consumerization of agent world versus kind of enterprise aspect of the agent world. And Dr. Guha is back, so we can have a lively conversation. What makes sense? If you look at the internet in the 80s, it was like IBM and DEC and Cray supercomputers and mostly mainframe companies actually sitting at Route 128 around Boston. And they lost the battle to companies that were thinking kind of consumer first, Bill and Steve's of the world, who said, hey, you know what? The PCs are going to actually build the network of tomorrow. I think the momentum very quickly shifted away from Boston to Silicon Valley when it came to building the internet on the web, although the World Wide Web was being designed at MIT with Tim Berners-Lee. So I'll ask the same question to both of you.
I'm sorry, I have to protest over here.
Go ahead, Dr.
What
Goha.
happened? Here is my version of what happened.
All right.
The internet stood not for a single TCP/IP, but TCP/IP was supposed to be internetworking, which is why Cisco's logo is a bridge. And it actually had an uphill battle. There were proposals from IBM and others to have very, very different kind of networks. And in fact, IBM really fought it very hard. I think IBM was Token Ring, etc. The place where things changed was when, in response to the Japanese fifth generation project, the US did this, introduce its big supercomputer project where you had these five supercomputing centers in San Diego, Urbana-Champaign, and so on. And they decided that the way in which faculty could and universities could access these supercomputers was through a network that ran TCP/IP.
Hmm.
That was the thing which made it really win. And then Wind's second big contribution was he introduced email over TCP/IP with POP, and then IMAP came along. In terms of the web itself, it was just fortunate that um, Jobs picked TCP/IP as the protocol, as the networking protocol for the next machines. And Tim BL, sitting in CERN, not at MIT, in CERN in Switzerland, had um, a next machine. And he had a project where you had these companies, researchers from different countries come with their own phone book directories. Okay. And he had to network all of these things together. And the justification for the first web browser and the web server was to integrate different phone books. And then Andreessen saw that Andreessen started off by trying to say, is there a web mode for Emacs? And then Eric Bina convinced him, no, 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 we need to do a whole new thing. And the reason why the particular set of widgets exists in HTML today is because that's what was there on his windowing system and Bina's windowing system in CSA And then Andreessen came to Silicon Valley, and Tim Beale and Mike Tertuzos convinced Tim Beale to come to MIT.
Yeah.
Um, Sorry,
Yeah,
that
but I think no, it's fascinating, and it's definitely fascinating. But the examples you gave are all, I would say, kind of consumer facing. Email or the fact that scientists can talk to each other and so on is what really propel, as opposed to the other way around, saying, "Hey, I have a database, and I just want my databases to talk to each other." So I just want to kind of add that
that's
subtle point that the scale came because there are millions, maybe billions of people online, and that's where all the innovations came. And because we have, as you said, HTTP and HTML that's used on the World Wide Web, the same systems also get used internally on the intranet. On the intranet, we don't go and say, let's use something other than HTTP because we are intranet. We say, let's use the public protocols also for intranet systems.
Yeah, look, it's going to be fascinating. I don't know how, and the reason I'm not saying that it's going to go consumer first or enterprise first is not because I have um, uh, of I just don't know, and it's going to be utterly fascinating. So if PCs took off initially because of Lotus 123, and Lotus 123 was not used by consumers; it was used by people inside companies. The web took off actually in universities first, and then from there it spread everywhere. Where is it going to go? Enterprises tend to be much more tolerant of complexity, enormous amounts of complexity. Um, Consumers are not, and my personal I'm personally attracted towards reduction in complexity and increase in functionality while keeping complexity the same or lowering it. So I'm attracted towards the kinds of things I showed you. It's also just fascinating to have a sort of see ecosystems develop like that, right? I'm being fortunate to have been part of a few of those, and just taking another big swing at it. So
Fantastic, fantastic.
I mean, here is the way I phrase it. Here are the daily problems of that so many of us face, and then I don't want to call it problems given everything that's going on in the world, which is what do I cook, where do I eat, what do I stream, what do I listen to, and the answers that you have and the things that you have. Every family faces like, what are we going to stream today? The interfaces are just not really rich enough. I want something that is far, far richer. Um, and if I can do that, and if I can give it to everybody and have a million points, it would be fascinating.
Absolutely, absolutely. Thank you, Dr. Goha. Thank you, Sam. We're going to move on with our program, and we're going to have bang, bang, bang. We're going to see 5 papers that are sharing with you how to think about this hybrid model of creating a lightweight index for this registry. And as we saw earlier, we have co-authors from many organizations. These folks are working day in and day out, late nights, weekends, trying to make progress in this field, being very inclusive, really get into the conversation. If you want to join us and write these documents, and you also see that a lot of coders here. This is the GitHub that's very active. It already has a whole bunch of papers that are coming together, and so on. So we're going to go through each of these papers today in about 12 minutes at a very rapid pace. So feel free to look at that. We'll post these links in the chat as well. But yeah, I'm going to hand